Welcome to the next video. In this video, I wanted to start using unit tests in our code base here. So I will introduce unit tests for our Vector2D class. And for that, I'm here at first on the official documentation of the unit test module that is built into the standard library of Python. Also, I will introduce you to the external third-party package, which is called PyTest. And at first, you may have the question, what are unit tests? Unit tests are tests for your code to check if the code is working as intended. So if you, for example, want to add two vector instances, as we saw before, you can check with the unit test if the result of this addition method is correct. So you execute a Python command, and the result, so the return value of this Python command, is then compared to the expected output value. And for that, we can use the unit test module. And here I just read the main article here. The unit testing framework, very nice sentence, was originally inspired by JUnit and has a similar flavor as major unit testing frameworks in other languages. If you have already worked with a unit test framework in like Java or C, C++, etc., they are all kind of same. So most unit test frameworks have a pretty similar syntax, and that is good. So you don't have to learn something completely new. It supports test automation, sharing of setup, and shutdown code for tests, aggregation of tests into collections, and independence of the test from the reporting framework. So what I will show you at first here are test cases. So here we have a basic example. The unit test module provides a rich set of tools for constructing and running tests. This section demonstrates that a small subset of the tools suffice to meet the needs of most users. Here's a short script to test 3 string methods. So here, for example, we import from the standard library here with the unit test module. Then, and that is the next step, we would create a class for a specific test case. So, for example, if you have a library with 3 classes that you have implemented and you want to test all 3 classes, you would in general create per class that you want to test a test class. So here, a test string methods class is created, and this class inherits from the unit test.test case. That is the most basic approach to just implement tests with the unit test framework. So then for every method, for example, you want to test that you have implemented in the concrete class. So for example, for our Vector2D class, we could now create for each method that is implemented in the Vector2D class, one test method here in the test class. So for example, here are the methods test upper, test is upper, and test split, for example. Then in each of these methods, which can be a single test, or you can combine multiple tests into one test function, that would be also okay. Then you just execute a command. So for example, one method from our vector class, and then we will compare the returned result of the method with the expected result. So for example, here we would test if the return value of the upper function is equal, so here assert equal is equal to the expected output here. The next test method here would be, okay, foo.isUpper would return, for example, true for this string here. So here the test is called assert true. So the underlying test would be if this method or function or whatever would return true. And for kind of all possible tests that you want to have in your code, there's one of the assert functions here. So for example, if you want to compare if 2 values are equal, you can use assert equal. If you want to compare 2 values that shouldn't be equal, you could use the function assert not equal. Or if you want to just here, assert some Boolean types, you can assert true, assert false, and so on. Okay, this is the basic test case here that is used for a class that we can implement now. Then you can run the unit tests via the unittest.main method. So this framework here has a main method then, and this method would just run all tests that are defined in this test case here. The output then would be, for example, if we have implemented 3 tests, that unit test has run 3 tests, and if one of these tests would fail, we would get an output message. So then we would see, okay, our code isn't computing the value that is expected to be. Next, we will use here the PyTest framework. And the PyTest framework makes it easy to write small tests, yet scales to support complex functional testing for application and libraries. The PyTest framework would just scan your code and looks for any methods or functions that would start with test underscore, for example, and would then execute them. And the good thing here is with PyTest, you would get a pretty nice command line output here, because if a test would fail, you want to know why the test failed. And here we would get such an output in the console. So we would see here, there's an increment function, for example, which just increments an integer value, for example. And here the assert statement is increment of 3 equals to 5. And since increment of 3 would return 4, this equality operator here would result into a false value. Hence, the assert statement would be false, and we would get here an assertion error. So the test would fail for this test function here that would be defined. And the good thing here is, as I said, you would see in which line the test failed and why the test failed. So here you would see 4 equals 5. So the result of increment of 3 is computed and here pasted into the error console message, which is pretty nice, and through that you get a good overview why a test failed. Okay, so for now I will go into the prepared code here. I have prepared some unit tests for our vector2d class, and the important thing is you can mix the standard library unit test framework with using PyTest, for example, which I will show you right now. So here I have created a class that is called vector test. It inherits from the unittest.testCase class. So it's a base class now. And this base class has a special method, which is called setup. And the setup method would just set up some variables that you want to use in the other methods of your class here. So if you want to use, for example, 3 different vectors, v1, v2, and v3, you can set them up here in the setup method and just store them as a member attribute, as a member variable, and you can use them in all of the test functions. So then important to note here is all of the test functions here starts, as I said, with test underscore, because PyTest will scan for this syntax. So if I want to, for example, test the equality function, let me jump right into here the dunder equal function. I have just created for this function, or for this method, a whole test method here, and I just assert not equal, for example, that v1 and v2 are not evaluated as equal, since these 2 vectors have different values, for example, they shouldn't be treated as equal. Then furthermore, here I have created a new vector instance with the values -1 and 1, which has the same values as the vector v2. So here I have a statement assert equal, and this assert equal should be true since v2 and the expected result variable share the same values, and hence our dunder equal method here should return true, since I check here in the dunder equal method if the x and y coordinates are the same of both vectors. Okay, so then I would have added some more tests, for example, for the addition, for the subtraction, multiplication, and division, for example. If I want to run it now, I can run it with some different approaches. For example, I can just run this Python file here, since I have set here this unittest.main statement. So if I run the Python file, I would see here all 5 tests were executed in 0.001 seconds, and none of the tests raised an error. Because of that, we get an OK message here. If I now would add here an assert statement that shouldn't be true, so for example here, instead of assert equal, I add assert not equal, now the unit test should fail here. And as we see, here we have a fail in the test diff method of our vector tests class. And we see right now here in line 51, and we would get here an assertion error, for example. Okay, so then we see, okay, we ran 5 tests, but 1 test failed. If I now remove here the assert not equal and instead we use the assert equal, the test should now be working. And with these unit tests, you can just evaluate if your code is working correctly. One more remark here is how we can start PyTest now. That's a bit tricky since we have here a nested directory structure. Normally PyTest is used when you create packages, which we will use later on in the next chapter. So for now I will call here PyTest, and then I pass in the directory where the tests should lie. So I say here chapter 3 code testing / unit testing / and then PyTest would find all files that start with test underscore. So PyTest scans for a certain file naming. So all files that include unit tests should start with test underscore. Also, as I said before, all functions or methods here that should be tested by PyTest should also start by test underscore. So for files and for the functions or methods, they should start with test underscore. Furthermore, as you will see in the next chapter, for modern packages, you will create a subdirectory which is called tests. So PyTest will look right into the tests folder. I can give you here a little sneak and peek. So here we'll see for the package that we will create in the future, I will create a tests subdirectory where our test vector.py file will go to, for example. So this is how you can create a simple test case here with unit test, and how you can run it via unit test, or how you can run it via PyTest. That's enough for the moment, and we will cover more unit tests in the next chapter when we will create our own package. So for the moment, that was the introduction to unit test. We will cover more about unit tests in the next chapter. Okay, then I will see you in the next video. Bye bye.